So up next is the Atomizer team. The Atomizer team took the idea of ideas and decided that those should be navigable. So give your undivided attention to Atomizer.
Hi, I'm Anthony Watson. This is Calvin Lynn, Truman Purnell, and our other team member, Kieran Derfus, couldn't be here today, but together we built a web application called Atomizer. So with this application, we wanted to empower users who might be looking to dive deeper into different concepts or topics by spotlighting the concepts most closely related to them. But instead of having to sort through the noise of a list of Google links or a Wikipedia page, the data is more focused and is rendered to so that the related concepts are rendered using an interactive visualization. So say we have a user, Jordan, who hears from a friend that she may be able to learn more about the internet and the different technologies that go into it by attending something called, I don't know, a coding boot camp. So she hops over to atomize.live to learn a little bit more. So a search of code boot camps returns this web-like structure called a force graph, where the initial query is in the center, and by clicking any additional child node, a new search is returned with that query as the new keyword. And that's done by grabbing the user's input off of the request query object and then making an additional AJAX GET request to Wikipedia using that same input using Axios. And the entire process is asynchronous, allowing for the data to be displayed in real time. So the benefits there are twofold. We don't need a database to store massive amounts of information, and we can display the concepts without having to refresh the page. So I'll let my friend Truman talk about the data flow.
Thanks, Tony. So we're on the front end, and we have a query, and we need to find the related links. So it's kind of hard, right? If you have a word, what on earth is related to that word? So we found Wikipedia to be a really excellent model there. So the first thing we need to do is sanitize this query. It could be spelled incorrectly. It could be some concept that doesn't exist yet that's just in the mind of a crazy individual. So once we've sanitized it, we grab the raw HTML for the most relevant Wikipedia page. And now we basically just have a list of links. So how do we figure out which of these links are most relevant to our article? From here, we use basically the frequencies of the links inside the article along with some contextual information about where they appear. And we found this to give us some pretty great results. So now we have our 8 links, and we're tasked with integrating them back into our force graph. So the way our force graph is stored is an adjacency list. Namely, each node has a list of nodes that it is connected to. So with our incoming 8 nodes, we simply hash the titles, look up if that hash is inside of our force graph object, and then if it is, just reassign the reference. And that way we can sort of build on the fly without deconstructing and reconstructing a list every time. So here to tell you about the force graph is my friend Calvin.
Thanks, Truman. So our application on the front end utilizes React, D3, Redux, and CSS for styling. First, I'm going to talk about D3. D3 is a JavaScript library that allows you to take data sets and create visualizations from it. So for example, a force graph, which is what we built, or like a bar graph or whatever. And in our application, we took data from our backend, plugged into D3, created a nice mind map force graph as what we shown earlier. Typical D3 codes will look like what we have here on the screen. In this case, we create an SVG element, insert it into the HTML DOM, and we set the size to be 600 by 600 pixels. Similarly, React also renders directly to the DOM, but it does so through a virtual DOM system. The virtual DOM system is used so that React can update individual parts of the DOM. So for example, if you type something into a search bar, then it'll update the state. And then if you hit enter, it'll render something without the whole page refreshing, or if you hit the refresh button on top of your browser. And now I've said that both React and D3 render to the DOM, so we now have a problem. How do we get to combine them together in a coherent way? We decided, after much research, that we don't combine them, and we let D3 do its own thing, and that is to render SVG elements, which is the pretty graphs and stuff. And we let React render everything else, which is the structure, such as the search bar, the title, and so forth. We decided that this was the best approach because it took the strengths of both libraries, and we also didn't have to try to bend one library to kind of fit the other library. And that is our presentation on Atomizer. If you liked our presentation and app, you can check us out at atomize.live. Thank you guys all for tuning in.
If you want to like that post or like that team, like the post and like that pinned comment. And actually, I was muted because I was actually playing with Atomize.live. It's actually really cool. So, very nice job.
Yeah. I want to mention they have some really cool insides as well as outsides. That like pipeline they were talking about with how they were querying Wikipedia, they've got these nice little functions that they've got in their source code. So I encourage you to check out their source code as well if you're looking for inspiration.